The research investigates the interpretability of vector quantization, VQ, in model-based reinforcement learning, MBRL. It examines whether VQ provides semantic information about entities in the environment, focusing on the iris MBRL agent. The study uses GradCam for qualitative and quantitative analysis to determine code consistency and semantic grounding. The findings indicate that VQ lacks the necessary constraints to ensure codes correspond to semantic concepts, disproving the intuition that VQ alone is sufficient for interpretability. The research suggests that latent semantic alignment is needed alongside discretization to make latent spaces generally interpretable. This work contributes to the understanding of VQ's limitations in MBRL and highlights the importance of considering both semantic alignment and discretization for achieving true interpretability. Here is the combined summary. The paper explores the interpretability of vector quantized, VQ, codes in model-based reinforcement learning, MBRL, using the state-of-the-art MBRL model iris. The authors apply GradCam to the code inputs of the decoder to generate heat maps that highlight the regions of the input image most influential in selecting each code. They evaluate the quantitative properties of the learned codes by measuring code consistency over agent observations and episodes. The experiments are conducted in the Crafter environment, an open-world survival game, where the model is trained to convergence and a dataset of 127,434 transitions is collected. The authors find that 90% of the heat maps contain all zero values, and 477 out of 512 codes have non-zero heat maps, resulting in 205,231 heat maps for the final dataset. The results show that the heat maps from a code focus on the same regions of the image, especially for more frequently occurring codes. However, the codes do not consistently associate with objects or concepts. To quantify code interpretability, the authors compare the embeddings for each crop from a pre-trained ResNet 50 model and calculate the mean cosine similarity between the mean code embedding and all embeddings for that code. The results indicate that VQ codes are inconsistent quantitatively and qualitatively, with low mean cosine similarity and lack of TSNE separation. The authors conclude that VQ alone cannot provide interpretability of transition models in MBRL due to insufficient constraints to enforce semantic disentanglement of codes. The paper highlights the need for a deeper study of discretization characteristics to ensure semantic associations, which is left for future work. The paper presents a comprehensive overview of recent advances in disentangled representations, focusing on the importance of interpretability and transparency in machine learning models. It highlights the need for understanding how different components of a model contribute to its predictions, particularly in complex tasks such as image synthesis and reinforcement learning. The authors discuss various techniques for achieving disentanglement, including vector quantization, hierarchical topological VAEs, and evidence-aware inferential text generation. They also explore the role of transformers in world models, demonstrating their sample efficiency and potential applications in areas like robotics and medical imaging. In addition to these technical contributions, the paper emphasizes the significance of sanity checks for saliency maps, challenging common assumptions in unsupervised learning of disentangled representations, and improving explainability through multipath attribution mappings. Furthermore, it provides insights into the challenges of benchmarking agent capabilities and the importance of compositional task representations for large language models. Overall, the paper serves as a valuable resource for researchers seeking to enhance the transparency and interpretability of their models, offering practical solutions and theoretical insights from a wide range of domains. Here is the combined summary. The authors investigate the interpretability of a neural network's codebook features, which are discrete and sparse representations of input data. They analyze the consistency of these codes across different input instances, identifying both consistent and inconsistent codes. The top 10 codes are found to occur significantly more frequently than the rest, with the most frequent code appearing in just over 1% of the dataset. The authors provide examples of consistent codes, which capture specific entities such as stone, grass, and water, and inconsistent codes, which exhibit varied and unrelated content. They also explore the phenomenon of code co-occurrence, where the model learns to combine codes to capture entities, leading to a lack of interpretability. The CO occurrence rate is calculated as the number of joint appearances divided by the average number of times the two codes are used. This concept is related to mechanistic interpretability, specifically the concept of superposition, where latent features are optimized to represent more features than their dimensional capacity, resulting in phenomena such as representing concepts with groups of features or individual features representing multiple concepts depending on the input. The authors present a heat map of CO occurrence rates for the top 10 codes, providing insight into the complex relationships between these codes. The authors' findings have implications for the development of more interpretable neural networks, highlighting the need to consider the consistency and CO occurrence of codebook features in order to achieve meaningful interpretability. The research discusses the CO occurrence rates of codes in a dataset, focusing on the 10 most frequently co-occurring pairs. Figure 4 illustrates the CO occurrence rates, with the highest rate observed between codes 344 and 424 at around 18%. Table 4 showcases examples of crops from observations where these codes co-occur, demonstrating consistency in what each code captures. However, the high consistency is limited by factors such as expected behavior within episodes and the small portion of observations accounting for interpretable samples. The study argues that vector quantization, by itself, may not provide meaningful interpretability to the extent suggested by prior literature, especially considering the need for extensive analysis to reach a sufficient amount of interpretability.